Welcome you all. I just come up with a problem from kinematics, especially the rectilinear motion based problem. A train starts from rest and uniformly accelerated to speed of 20 km per hour over a distance of 200 meter. Calculate acceleration and time taken. If further accelerated to the speed of 50 km per hour in 8 seconds, find the acceleration and further distance moved. So, by just reading out this question, I just understood it has two parts. So, up to this one part and this another part. Train starting from rest and uniformly accelerated to certain velocity. For that we need to find acceleration and time taken, and further it is accelerated to the speed of 50 km in 8 seconds. For that we need to identify the acceleration and the distance moved. So let's start taking the given data. So already I said I just going to consider as two parts. So first case 1. So first part is a case 1. So here in the case 1 it is given the train starts from rest. That means the initial velocity of the train is 0 since it starts from rest. At rest position there is no velocity. So initial velocity is 0 and uniformly accelerated to the speed. That means its velocity it is mentioned in terms of kilometer per hour. So 20 kilometer per hour. In a standard SI unit we have to bring it out. That means meter per second. So in order to convert it 20 into kilometer, in order to convert it into meter, multiply by 1000 divided by hour to second, we need to multiply 60 into 60. So at that time we will get 5.55 meter per second, okay, as a velocity, and distance is given distance of 200 meter, okay, that is a displacement s. What we need to find the acceleration and the time taken, both of them we need to find it out. What is next? We shall take this second case data. What it is given? The further accelerated to the speed of 50 km per hour. What it means? Actually the train is just maintaining the speed 20 km per hour. Here it is given and it is further accelerated. So the initial velocity u, which is 20 km per hour, okay, 20 km per hour. So here 5.55 meter per second is the initial velocity, okay, and it is further accelerated. That is the final velocity for this case 2, that is 50 km per hour. So here as well we need to convert the meter into hour, okay, just like this. That means 1000 divided by 60 into 60 into 50. If you put it, you may get the answer as 13.8 meter per second, right? What is next? It is given, it is for 8 second, that's time is 8 second, right? So for that, to find for this data we need to find the acceleration a, what is it, and distance moved s. This is what we need to find it out. Just move to the solution part. Start with the case 1. So in the case 1 it is given. So once you got the question from the the rectilinear motion, just you have to be ready with the 3 equations of motion, okay. So just for the understanding in a better way, I just going to write here s is equal to ut, displacement is equal to ut plus 1 by 2 at square, v is equal to u plus at, and v square is equal to u square plus 2as. These are the three equations we just learned. Okay, we just learned. So by this three, we just going to get the unknown datas, right? So let's start to identify the acceleration A. How will you identify it? From which equations? So here initial velocity and v is available, s also available. We need acceleration. Then which equation is possible? Look at this. V, final velocity, initial velocity, and time is unknown, right? So we need to find time here, so it will be ruled out. So here time as well unknown, so we cannot identify the acceleration. So if you look into this v square relation, v square is equal to u square plus 2as. So v is known, u is a known one, and a is unknown, that we need to identify it, and yes, displacement is known. So if you go by this equation, it will be easy to identify the acceleration v square u square plus 2as. So here v square is given as 5.55, which is equal to u 0 square plus 2 into acceleration a into s. S is 200 meter. Okay, so from here we can get the answer for a. So just do the simplification. I just going to take a. So here 5.55 the whole square. Okay, 5.55 the whole square divided by just doing the cross multiplication. Only you are keeping the a. So 2 into 200. So now if you do the calculation, you will get the answer for acceleration 0.075 meter per second square. This is the acceleration data. What is next? What is next? Identify the time. So time taken to reach the particular distance 200 meter when it is accelerated to 5.55 meter per second. So in order to take the time, which equation we shall follow? Final velocity known, initial velocity known, acceleration is known. Now time is a required one. Can you move with this equation? Yes. So here if you put it, v is equal to u plus at. So now acceleration final velocity is given 5.55, which is equal to initial velocity 0 plus acceleration a into time. Time need to find it out, right? So acceleration answer here it is given 0.075 into t. So if you do simplification, 5.55 divided by 0.075, just we kept the t and just do the cross multiplication. So this is how the simplification will be, and now we get 73.33 seconds for a time. So first set over, case 1 is over, second one is a case 2. The case 2, just go with the same equations with the given data here. The initial velocity here it is 5.55 meter. Okay, accelerator from the particular end, right? So here it is the initial and final, it is time is given. Record part is the acceleration. Okay, so here which equation is possible? If you put the equation v is equal to u plus at, then I can say you shall get the acceleration since final velocity, initial velocity and time is known. So here velocity, final velocity is 13.8 meter, which is equal to initial velocity 5.55 meter plus acceleration into time 8 seconds. So do simplification, it will be 13.8, just keeping a, take it to next side. So 5.55, okay, 13.8 minus 5.55, divided by this 8 will be in the lower, right? So when you are doing it, you will get acceleration A is equal to 1.037 meter per second square. Okay, this would be your answer A. Now identify this displacement, distance moved. Okay, so when it is further accelerated and moving with the accelerate velocity 50 kilometer per hour in 8 seconds, what is the further displacement moved which is asked in the question. So in order to identify it, I just going to apply this one. Displacement S is equal to ut plus 1 by 2 at square. When we apply it, displacement need to find it out. U initial velocity is 5.55 into t which is given 8 seconds plus 1 by 2 of acceleration 1.037 into time square. Time is 8 square. Just do the calculation. You will get what's the displacement here. The further acceleration gave the displacement as 77.2 meter. So this is the displacement. Okay, here acceleration A is equal to 1.037 meter per second square and the displacement moved is a 77.2 meter. I hope you understood how we have to take the given data and what are the formulas we need to use it of and how to solve the unknowns. I hope you understood. Thank you so much.